Hello, my name is Mirkov, and welcome to my quick introduction to discrete mathematics. The goal of this course will be to give an overview of all the important concepts that I feel discrete mathematics can offer a beginning computer scientist or programmer. Let's begin. Discrete math is a set of different branches of mathematics. This includes formal logic, set theory, graph theory, etc. Discrete math, by its nature, deals with discrete objects, that is, things that are countable. So you won't be finding pi or areas under curves here for continuous functions. If you're interested in those things, obviously calculus and its derivatives will please you, but we will not be talking about any of those topics. Discrete mathematics is useful because all computers are based on discrete mathematics, and as a computer scientist, you should know how it works, why it works, and what a computer can do and make use of in terms of these mathematics. Computers are built out of component parts. One of those parts is the CPU, which does all of the mathematics relating to calculations the computer is doing. All mathematics a computer is doing is digital, that is discrete values, unlike analog signals, which will appear in nature. As you can see, unlike analog signals, digital signals will only change their value at specific intervals of time determined by the clock speed of the CPU. Now that we know that digital signals are not continuous functions, let's examine decimal numbers. Likely, you're all familiar with decimal numbers. For each place value, there is a number from 0 to 9, and when we put them all together, we get a value as seen on the right-hand column. These numbers can be added together, and when the value of a single column goes above 9, then we carry over a decimal place to the left. Binary numbers actually work very similar to decimal numbers, except for instead of having values from 0 to 9, they only have values from 0 to 1. Therefore, instead of having a tens digit as the second place, there is a twos digit. As you can see, to get the equivalent value of what this binary number is equal to, we simply multiply the digit place by the value in that digit place and sum them together. As we can see, two binary numbers can also be added together. For example, here we have 32 and 32, and when we add them together, we get 64, just by using carrying over the place value, just like a decimal. Since all computer code, as we know, works on digital signal, we represent that digital signal as a binary signal, either zeros or ones. In a computer, this is represented by either high voltage or low voltage. Depending on whether the voltage is high or low when the clock hits, that determines whether the signal is a 0 or a 1. This is all for Lecture 1. At the end of each lecture, I'm going to put some practice problems. The suggested practice problems here involve learning some vocabulary, memorizing some powers of 2, and practicing writing some numbers in binary. In addition, I ask that you practice some binary addition, and then also think for yourself about how many different numbers can be written with a byte, and what's the highest decimal value that you could write with a byte. Then, finally, is a free-form question. Think about whether you can represent fractions, decimals, or numbers such as pi in binary. If so, how would you do it? I'm not going to discuss how computers actually do this, because I think it's outside of the purpose of this course. Finally, yes, I know that I went quite fast. However, this is a video format, and so that you can pause at any time and review the material, so I highly suggest that you do that. My goal is to speak quickly and to go through material in a way that is very comprehensive and yet quick. Okay, I hope to see you in the next lecture.